back to our channel, The Classroom. Today I am back with the first chapter, that is matter again. We have finished that is just before the change of state and thought of again starting with a new part, that is interconversion of the states of matter. So I said I'll be starting from this part only, and till the last class whatever we have done, it was all about the difference between solid, liquid and gas and their properties. So this is of class 8 chapter. Today we can finish off this, just leaving this portion. We don't have anything matching with class 8 about the matter chapter. So let's start with physics today. Okay, now as you can see, I have already drawn the diagram. This diagram I have already shown in chemistry chapter also, because the same chapter resembles each other more a bit. So let's just have a revision of this part, as we have already discussed this in chemistry. Now, from solid to liquid, the change from solid state to liquid state is known as melting. Okay, and what about the melting point that I said? The temperature at which solid changes to liquid state is called melting. Okay, for melting, again I'm repeating once more, when you are saying the change of solid to liquid at a particular temperature or at a constant temperature is called melting. Okay, and one more thing about melting point is the temperature at which, you can start this definition in this way also. Okay, the temperature at which the solid converts itself to liquid state is called melting point. Okay, then coming to the liquid to solid, that is freezing point. Okay, whenever a liquid changes to solid at a particular temperature or at a constant temperature is known as freezing. And what about the freezing point? It is the temperature at which the liquid converts itself to solid state is known as freezing point. Same for your boiling. Liquid changes to gaseous form. Okay, it is known as at a particular temperature or at a constant temperature, that is known as boiling. And for condensation, sorry, gas changes when a gas changes to liquid state at a particular temperature or at a constant temperature is known as condensation. Similarly, again same thing, that boiling point, the temperature at which liquid state converts itself to gaseous state is known as boiling point. And for same thing for gas to liquid, when at a particular temperature when gas changes to liquid state, okay, is known as condensation point. Now this particular temperature that I am talking about, okay, is constant. Okay, there is no, you know that in every all these, like solid to liquid, liquid to gas, we have to put in energy over there. Okay, so that the molecular motion increases and the change of state will take place. Now this particular energy that I am talking about is not in the form of temperature. Okay, there is no particular change in temperature, neither increase nor decrease in the temperature. There is only one change that is occurring, that is change in the energy. The heat that is providing is only in the form of energy. We know already that the molecules have kinetic energy in between them, right? Whenever they are in the solid state, they are vibrating in their mean position. Now that energy is nothing but the kinetic energy, which is helping them to move. Okay, now let me say, before I proceed to the next part that I am going to say, kinetic energy and potential energy. You know these two energies. These two energies are part of one, that is, it is a combination of one energy, that is mechanical energy. Mechanical energy has two parts. One is kinetic energy, one is potential energy. Now what is kinetic energy? Kinetic energy is the energy which is possessed by a body due to its motion. Due to its motion. Okay, that means the molecules, whenever they are in motion, they are having the kinetic energy. Right? Now, the next part, that is a potential energy. Potential energy is the energy possessed by a body due to its position or at rest. Okay, so this kinetic energy was present in the molecules when they were vibrating. After they got more amount of energy, okay, this kinetic energy has increased because of the heat that it has received. So they have started more, that is moving more violently. As they have started moving more violently, they are moving apart from each other, that is in the solid state. They are moving far apart from each other. Therefore, the attraction power is also decreasing. Therefore, what is happening is it is changing to the liquid state. Now, as it is changing to the liquid state, the molecules have already gone too much far from each other. They are in their random motion by that time because they have got too much of separation in between them, too much of space in between them, and in between them, this kinetic energy has already changed itself to potential energy, because kinetic energy no more stays in motion, that is, it helps in motion of the molecules. These molecules have already gone too far and they are now in a particular different position. So due to position, this is no more the kinetic energy, this is the potential energy. Okay, now, so that means this particular heat that has been provided is not to increase or decrease the temperature, it is just to change the energy forms, okay, from kinetic to potential. I hope I am very clear. This was for the explanation of solid to liquid state. Okay, that is how solid state is changing to liquid state. This explanation is known as the explanation of melting by molecular model. Okay, that how the molecules are getting separated because of the kinetic energy getting more amount of energy from the external source and therefore converting itself to potential energy. Now this particular heat or the energy that we are getting is known as latent heat of fusion. This latent heat of fusion is only there for the change of solid to liquid state or for liquid to solid state. Okay, this latent heat of fusion is only present in between solid and liquid, not for liquid and gas. This energy form is known as latent heat of fusion. Okay, I hope I'm clear with this. Next part, liquid to gaseous form. Now liquid to gaseous form, we know that is the boiling, and we can also say that, tell me about the explanation of boiling or vaporization through that molecular model. Same explanation, liquid, the molecules are already far apart, right? Suppose it is contained in a, it is there in a container. That means it has a particular, it is inside a particular, that is, it has already taken up the shape of the container, right? Now, when it has already taken the shape of a container, it is colliding with the walls of the container. It is also colliding with each other, right? So as it is colliding with each other with the walls of the container, it is already in a fast motion because it is exchanging of energy is taking place. As soon as you are providing heat to that liquid, what happens is, same thing, the energy between them increases. Okay, when they again come in contact with that closeness or like in a container, they are again in that moving state, colliding with each other, they are having the kinetic energy in them. As soon as heat is provided to them, what happens is their motion increases to such an extent that they break all the bonds, that is a force of attraction between them, and moves two apart and changes to gaseous state. Now when they reach the gaseous state, it is already, there has been a change in the transformation of energy, that the kinetic energy has converted to potential energy. Okay, now this part is known, this heat or this energy which is already present, that is known as latent heat of vaporization. Latent heat of vaporization. Okay, so between solid and liquid, it is latent heat of fusion. Between liquid to gas, it is latent heat of vaporization. Okay, it is a latent heat. This hidden heat is known as the latent heat because this heat is not changing in a temperature. It is only changing the movement, the energy of the molecules. So this is the hidden heat, okay, which cannot be understood in the form of temperature. So this particular energy is known as a hidden heat, which is, in other terms, it is known as a latent heat. Between solid to liquid, it is the fusion. Between liquid to gas, it is the vaporization. I hope I'm very clear with this part now. Okay, next coming to the sublimation deposition part. I have already explained that sublimation is the change of solid state to the liquid to the gaseous state without converting itself to the liquid state. This particular word I have said before also in chemistry class, that without changing itself into liquid state is very important to write in the definition. Okay, so that portion is known as, this particular process is known as sublimation. Now what other examples? We have already done that. Camphor, naphthalene, NH4Cl, that is your ammonium chloride, and your dry ice. These are the examples of sublimation. Okay. NH4Cl is particularly a solid. Whenever you heat it, it directly converts to white fumes. Okay. So that is the example that how it converts itself, that is to gaseous form. This is a solid dry NH4Cl. Okay, it's a powdered form of salt. So whenever heat is provided to it, it doesn't change anything to water. You can simply see that white fumes. You can also collect that if you cover that white fumes. Okay. So as it collects after that, if you cool it, again it will convert back to the same dust that is solid. So it is a very reversible process. Okay. Now, coming back to deposition, gas changes to solid without converting itself to liquid form is known as deposition. So this was what was your example. Deposition, again you can take the example of NH4Cl. That is, it gets, that is when if you collect that white fumes and cool it, it will come back to NH4Cl again. Okay, so this is the whole process of interconversion of states of matter. In between I have also explained about the molecular model of this change of solid to liquid and liquid to gas. Okay, and yes, last time again I have said about evaporation. I will repeat here also once. Evaporation. Now this evaporation term, you can use the evaporation term also, boiling term also. But when to use what? It comes whenever we have two things in that. Okay, that is, boiling is occurring just because we are providing a heat from the external source. Evaporation does not need any extra amount of external, that is heat from the external source. Okay, evaporation can take place at any particular temperature. It does not need a particular temperature only when evaporation will take place. No, it can take place at any temperature. I have given so many examples of drying of cloth under the sun and so on. So these are examples of evaporation. Okay, now there are some of the factors which I will be discussing with you right now. Like, evaporation is a very slow process. I have even given the example of that drying of clothes. It takes like 2 to 3 to 4 hours to get the clothes to dry up, right? But in case suppose it is boiling, will it take so much of time to get dried up? No, it will just automatically get dried up within a few span of time, 30 minutes, 40 minutes and so on, maximum, maybe, right? So there is a time limit for it. It is a very slow process and a gradual process. Okay, it happens one after the other, but for this boiling it takes up very fast. Okay, because our external source is there to provide heat to it. So it takes very short time to get converted from liquid to gaseous state. Now suppose we are talking about how evaporation brings about a cooling effect. Okay, now cooling effect, you will feel, Madam, how will we be thinking about this cooling effect? Cooling effect in the sense is that suppose we are sweating. You know this climate nowadays, right? It's very hot, it's very like sweating type of climate. Precipitation is too much. Sometimes humidity is also there, for which we are sweating, cloudy weather sometimes. Okay, now what happens is we sweat, right? Now when we sweat, you will see that there are droplets of water or sweats on the surface of the skin, right? You're switching on the fan and you will feel that you're feeling cooler, right? Very good sensation comes. Why? What is the reason that we get that cooling sensation when already there is sweat in our body? Sweats happens because we feel hot, right? Those are some excretors of our body that comes out in the form of sweat. Okay, those have salts and many other sodiums in that. Okay, now when it is coming out, it is in the, suppose it is in the surface of the body of ours. Okay, we know that liquid changes to gaseous state only when it receives some amount of heat, right? So from where will it collect the heat to convert itself to gaseous form? Obviously from the environment, right? Because the sweats are on the top of the skin. Already we can see the sweats on the skin. So that will get converted to gaseous form within some fraction of second maybe, or fraction of minutes maybe. Okay, so it is going to collect that heat from the surrounding because it is already very hot. Okay, so as it collects the heat from the surrounding, it transforms itself to gas. And whereas what happens, as it is collecting the heat from the surrounding part becomes cooler as respect to the other places. So therefore, whenever we are switching on the fan, we will feel that we are feeling cool. Why? Just because of this. I hope I'm clear with this. Last day, when I was teaching chemistry, I have also given the example of the patient having high fever and why do doctors suggest putting wet clothes on the forehead. Right, that also I have said. Even you can see this also, this is a very good example. That is, during the summertime, we keep water in the earthen pots. Have you seen many people keep it in the earthen pots? It's not only in the villages. In the cities also we do keep in the earthen pots. It's very cold, as if it's a freezing cold. Okay, these waters are. How? Now, these earthen pots have very small minute pores which you cannot see so much. But yes, it has minute pores within which what happens is this water gets collected inside the pores. Now, as it passes through the pores, this earthen pot becomes wet, right? You know that as it becomes wet, it will try to evaporate. That is, the liquids will try to change itself to gas. Now, whenever this liquid will try itself to change into gas, it will take the heat from the surrounding and get converted into gas. Now, as it is converting itself to gas, here now the thing is, sorry, inside the water it becomes cold, right? Now, let me tell you, it is not going to take, because this water is not going outside the earthen pot. Okay, if you feel that, miss, yes, madam, why not from the outside is taking heat and then it is cooling? No, because the water is not sweeping down. You can see a earthen pot which we have taken, the water is not sweeping down. But yes, when you touch it, when you drink that water, you can feel the sensation how cold it is. So obviously that means it is not from the outside temperature that it is getting cooled up. No. Yes, obviously that earthen pot has many pores in it. It is that is, it is sucking water. Okay, it gets, that is, the pores is sucking water over there. But the heat of this water was already present, right? So this vapor form is changed, or rather is changing because of the heat of the liquid inside the pot. The water when we are pouring, that is already hot. Okay, so the liquid that is inside the pores, which is getting vaporized, is taking the heat from the liquid itself. And as it is taking the heat from the liquid itself, that means this liquid is throwing off the heat that is already present in it, and therefore it is getting cooled. That is why the earthen pots outside it feels so cold. But have you seen that waters are dropping or dripping from that pot? No. But it sucks that water in its body because it has minute pores inside. Okay, and the heat for which the liquid is getting converted to vapor form is taken from the liquid itself, the inside liquid, for which later the liquid turns cold. This is the particular explanation of why earthen pots have cold water. Or if you keep water in the earthen pot, it remains cold. This is a particular reason. I hope I have tried to explain you that. If you are having any doubts, please do comment. Okay, it will be easy for me to get you back again. Next, now coming to the factors of evaporation, which will be the last part that I will be discussing with you in this chapter matter of physics in class 8. So this particular that is factors are that is affects the evaporation to much extent. The first one, let me come to it, is a temperature. Now temperature, it's obviously of the liquid as well as of the surrounding. If the surrounding temperature is too high, evaporation rate will be very fast. If the temperature or the boiling point of the liquid is high, it will take in much heat and the evaporation rate will be faster, and vice versa. Secondly, suppose we are taking a wide area of the exposure is too big. Okay, so there the exposure, that is the evaporation rate, will be too high. If it is a smaller area, evaporation rate will be very slow. Suppose you are taking a big beaker of water okay, and a small glass of water, okay, filled in it. So which will evaporate fast, the beaker or the glass of water? Obviously the beaker, because it is on a wide area. Okay, the molecules will try to escape out of the surface very fast. Sorry. So therefore exposure, that is area of exposure, is, if greater, evaporation rate will be much more than the less area. Next, coming to humidity. If the humidity is too high, okay, obviously you can understand the water of, that is the level of the water vapor in the atmosphere will be high. Therefore evaporation rate will be slower. It will not be able to take up the water from the like the clothes or maybe from some bodies. Okay, the rate will be much more slower. Then fourth one is, suppose the speed of the wind is very high. Okay, that is huge amount of wind is blowing. Then also you can expect a very fast evaporation rate. You will see sometimes it's not a clear sunny weather. It's actually a cloudy weather, but still it's not having so much humidity. There is too much of air in the, that is atmosphere. You are trying to keep the clothes for getting dried up. You can see within maybe 1.5 hours it's getting dried up. Why? Because of the speed of the air. Because it takes away the liquid particles and converts itself to vapor form. Okay, just because of the speed of the air. Because it also contains some type of energy which helps to convert the liquid to the gaseous form. So these are the particular factors on which evaporation depends. And one more thing that I would like to discuss is, that is, suppose this is the liquid, this is the particular, suppose it is a beaker or something like that, this is a particular liquid that is there. Now these liquids, I must draw it a bit bigger so that you can understand. Let me rub this off. See here, suppose no more interconversion is going on. Suppose this is a beaker, okay. Now as you are taking the beaker, suppose this is the water level. Now here are the molecules that is moving. Now these molecules are either like striking each other, okay, like this way, or like bombarding with the walls of the container or with the surface of the liquid, okay. As they are colliding with each other, there is exchange of energy that we have already known, right? So as there is exchange of energy, it gains so much of energy that it can reach to the surface of the liquid. And as it reaches the surface of the liquid, there will be excess heat here in the surrounding, okay, here in the surrounding, due to which it will collect, this molecule will collect heat from this and will evaporate. Okay, it will take the heat from the surrounding and will evaporate. So this is how it works. So evaporation is always taking place at the surface of any liquid. It is taking place at the surface of any liquid. It is a surface phenomenon. Okay, whereas boiling will not be a surface phenomenon, because we are giving heat to the whole liquid. Okay, so the whole liquid is getting evaporated at the, or like boiled up at the same time. But evaporation, it is only one after the one layer. That is first layer, then second layer, third layer, and so on. Whichever molecules get more energy, they go up, they stay here, take the heat from the surroundings and later on escape out. So this is how it gets converted to vapor forms in case of evaporation. I hope I'm very clear with it. In case you are having any doubts, please do comment, write to us, okay. This was the end of the chapter. I have already told you about all the conversions and everything. And yes, one more part, that is sublimation. I was talking about how, that is, it directly solids convert to the gaseous state. It is there also these particular solids in which goes for sublimation. Okay, that directly changes to gaseous form, like camphor, naphthalene, all these, NH4Cl, dry ice. These solids, the intermolecular attraction is very weak. The molecules have very weak intermolecular force of attraction. Therefore, with little amount of heat, it can move apart in a very wide state. Therefore, it directly converts to that is your vapor state, without converting itself to the liquid state. So this is just the molecular explanation of your sublimation. Because of the existence of very weak intermolecular force of attraction, these that is solids, which converts itself directly to gas, needs very small amount of energy for its conversion. Just because of that, these particular solids go for sublimation, not for any other changes. So I hope I have been able to clear all the points. Anyway, this is the end of the chapter. We will come back with another chapters. So till then, stay connected with us, stay well, and have a good day. Thank you.